Welcome back. You are attending the machine learning course with Python 3. We are at model 4. This is part of the classification, part 2. Okay, the model 1, 2, 3 we already completed. We are at model 4, that is the fourth course. Okay, and this course is given to you by Subaraj Academy. You are at lesson 2 of model 4. The model 4 lesson 1 was decision tree based on entropy criterion, and lesson 2 is on decision trees based on gini criterion. These are two popular criteria used for developing or drawing decision trees. So this lesson is dedicated to drawing decision trees using gini impurity criteria. Well, impurity basically. Gini impurity is a measurement, is a measure used to build decision trees. See, we used entropy to build decision trees in the previous lesson. Here we are going to use gini impurity to determine how the features of data set should be split. Data set should split nodes to form a tree. Basically, the entropy and the gini are used, they're impurities. So they are used to split the nodes. So we split the nodes in such a manner, the impurity is lower. If there is choice, you choose the path which gives you lower impurity. The gini impurities of a data set is a number between 0 and 0.5. So we say entropy between 0 and 1, but gini impurity is 0 to 0.5. A gini impurity indicates the likelihood of new random data being misclassified if it was given a random class label according to the class distribution data. Basically, it tells you about wrong classification, the probability of wrong classification of a new data set, new data. Let us take an example to understand this because this concept's a little high. So understand it, to understand complex when we use examples. We want to build a classifier that determines if someone will default on the credit card. The whole world is having a credit card. Millions of billions of people are having credit cards. To determine whether a person will default credit card, default payment due for credit card. So we have some labeled data with features. So to determine whether anybody will default on the credit card, we have features like age, income, credit rating, and whether or not the person is a student or not, whether or not the person is a student or not. So these are the four features. To find the best feature for the first split of the tree, the first split takes place at the root node. We calculate how poorly each feature divided the data into the correct class. So before, so as we know, the decision tree is first initially all the data points, the entire data set lies on the root. So you can split the data set using any other features. So before doing that, you must find out what is the impurity, how poorly each feature divides the data. This calculation would measure the impurity of the split. And we are calling it impurity. And the feature with the lowest impurity would determine the best feature for splitting the current node. This is the case when you go further down the tree also. This process will continue for each subsequent node using the remaining features. Okay, so you to decide which feature based on which we should divide the tree, we calculate the impurity. So in the previous lesson, we were doing it with entropy. Here we are going to do it with gini. Okay? So I'm just to make you feel comfortable, I'm giving you some example. So there are 4 features: age, income, student, and the example just we saw, and credit rating. So when you want to divide, the Gini index for the age is 0.343. For income, it is 0.44. The student or not is 0.367. And credit rating is 0.429. So which one will you choose? You choose age. Age has the minimum Gini impurity. So he selected as a root in the dictionary. So that's how we decide. Okay. We calculate the Gini impurity, Gini or Gini, whatever we call it, and choose the lowest, and then split the tree with that feature. How to calculate the Gini impurity? Consider a data set D containing sample from classes. The probability of sample belonging to a class at a given node, the probability of sample belonging to a class at a given node can be denoted as Pi. Then the Gini impurity of D is defined as D is equal to 1 minus sigma into 1 and is equal to 1 to k Pi square. So Gini impurity is calculated by subtracting the sum of the squared probabilities of each class from number 1, not this one. Okay. So this is the formula for calculating Gini impurity. So Gini impurity is the probability of incorrectly classifying a random data point in a data set. It's an impurity matrix since it shows how the model differs from the pure division. Okay, so guys, we are looking at a pure division where the index is lower, it's purer. So it's an impurity matrix since it shows how the model differs from the pure division. Unlike entropy, Gini impurity has a maximum value of 0.5. Very pure classification will be 0.5 and minimum of 0, pure classification. And we discuss that. So the last lesson we have been taking social network ads, but let us try with another data set, again taken from Kaggle. An experiment with the Gini index with another data set from Kaggle. So a marketing agency has many customers which use their service to produce ads for the client customer websites. They have noticed that they have quite a bit of churn in their clients. People are leaving. The clients are dropping. They basically randomly assign account managers, right now, but want you to create a machine learning model that will help predict which customers will churn, stop buying their service, so that they can correctly assign the customers most at risk to churn an account manager. See, basically how they try to overcome the churning is by appointing an account manager so that at a higher level he will take care of their problems. Luckily, they have some historical data. Can you help them out? Create a classification algorithm that will help classify whether or not a customer churned. So based on the past data, you can make a model for customer churning. Then the company can test this against incoming data for future customers to predict which customers will churn and assign them an account manager. Basically, the problem is simple. There is a company, telecom company, the marketing agency, that they got many customers. They use their services, produce advertisements on websites. So they want to predict in advance whether the customer will drop from them. So that is your job to make a classification model to help this company to identify the possibility or probability of churning of the customers. So they've got many fields. You should understand, when you talk about data set, you should understand many fields in it or columns in it. The name of the latest contact at company. See, they are serving many companies. So the name of the latest contact at that company where they are serving. The customer age, total purchase, total advertisement purchase from the company. The account manager, binary zeros equal to no manager, ones equal to account manager assigned. Years is equal to total years as a customer. See, this is a long-standing company. So number of years the customer has been in the company. Number of sites, number of websites that use this service. So onboard date. Date, the name of the latest contact was onboarded. Location, company, name of the client company, location, client headquarters address, all that. So once you created a model and evaluated it, test out the model on some new data. You can think of this almost like a holdout set that your client has provided, saved under new customers.csv. Then client wants to know which customers are most likely to churn given this data. They don't have the label yet. So this we have to use it for classification. And just think which are the fields you can use it for X values. Y value, churned out or not. The X values, name is not going to help, age may help, total purchase may help, account manager may not help, years may help, number of sites also may help. Other things are not going to help your classification modeling. So I will shortly show you the classification program in the Jupyter Notebook. Here I'm showing you the tree diagram produced by the Jupyter Notebook. You see years, gini, 0.28 is on here, the root, number of servers 720. Okay, if you need to add, you will get 720. And true and false, age is less than equal to 48.5, and the true place age is less than equal to 48.5. Gini 0.16 samples, and value is given. So then it goes on, you have the leaf nodes where they very useful to you, and the Gini values are less, 0.219, 0.092, 0, 0.269, and so on. So this is what was generated for the churning data, churn data. But I found the accuracy was not that good. So I wanted to confirm by drawing the decision tree using entropy as a criteria. Okay, so that also did not help. This one, with entropy, it also did not help. Okay, and the accuracy did not improve much. Then I took out the multi-class classification where the accuracy was good. I also used, you will also see the regression using Gini as a criteria. So I'm going to show you 4 programs. Program number 1 is using the churn data. Okay, the churn data, customer churning data. I'm going to show you the classification. Then I'm going to verify that with the entropy. Then I'm going to do a multi-class classification using the iris dataset which we saw in the previous lesson. And lastly, we'll look at the regression using the Gini as a criteria for the social network ad dataset. Okay, now let us go to the let's go to Jupyter Notebook. So this is what the first one. So this here I'm going to use gini as a criteria, impurity criteria, and I'm going to use the customer churn data which I downloaded from Kaggle. The other library import is same. So the data is new, not the customer churn. So I make a DF data frame with this data and then print the columns for the data. So it has got number of columns, names, age, total purchase, account manager, yes or no, number of years, number of sites, onboard data, etc., etc. So then I also wanted to have a feel of the data set. So I printed the head. So names are here, age, total purchase, maybe in dollars, account manager, no, in this all the cases, number of years, number of sites, onboard date, and location. Okay, and then we have the company, client's company, and the churning here. Yes, all of them have dropped out of the company. So what are the X values? 1 to 4. 1 is age, 2 is total purchase, 4 is number of years. I'm taking 1 to 4 as the. I tried with other combination also, but it did not help. So 1 to 4 will be the X values, columns 1 to 4, and 9 is the values. What is 9? 9 is churning. The 9 will be churned or not. Okay, so we can print that X and Y values. So we got it. Everybody has churned out. Okay, so these are the 3 columns on the X. Okay, so now we can split the data set into training and testing as we had done earlier. Now I'm going to use the decision tree classifier, and this is all for this second, that is export graph base, P dot, PAL, that's for plotting, and this is for accuracy score. So very important is create a decision tree classifier, not entropy, with gini as the spreading criterion. So decision tree classifier criterion is equal to gini, max depth is equal to 3. So then I put CL of fit, extend weight in the same. Then I put web prediction. Then accuracy, this is the same as yesterday. Okay. Then you make export the decision tree as a dot file, open the image file and show. So let's look at it, and I'll also try to do some modifications to show you what happens. Okay, the accuracy you got was 0.78. Okay, this is the confusion matrix also will give you the same thing, 0.78. Now I want to make a small modification. Of course, I did try with these equal to 4 and all that. The classifier max depth is equal to 4, 5, 6, etc. But now let me remove this altogether and see what happens. I'm experimenting. I'm not tried it before talking to you. I've been getting error also. Let's see what happens. We get 0.75. So they reduce from 0.78 to 0.75. It's okay, doesn't matter. So since the accuracy was poorer because we were getting 0.96 and all that, so I wanted to try with entropy to reconfirm whether the accuracy of this particular data set is poorer. So I the same data set I took, and with the entropy, I have experimented it. So import the data, import the libraries, import the data, and print the same thing, no? The columns, names of the columns. So you get the head like this, then you get assign x and y values, and then split test change split. No change after this, but here comes the change. Create recency classifier with entropy as a splitting criterion. Okay, recency classifier, entropy as a criterion, max and depth is equal to 3, and fit, predict, find accuracy. So let's see whether the accuracy improves or not. When you run this, you get 0.86. It's not bad, but not very good also. So this completes the, so we have compared both methods, entropy as well as gini criterion for classification, for binary classification. Okay. Now let us take the multi-class classification, like we then did with the IRI data set. I'll show you the multi-class classification. Yeah. So we are so far seen only binary classification. We are going to see take IRI data set, and there are 3 types of flowers. So the multi-class classification attributed to the data attributed to R. Fisher, the great genius in statistics. Import the libraries, and I want to look at the columns. So this is septal length, sepal length, sepal width, petal length, and petal width. These are the X features, predictors, X values, and species is the Y values. So if you print the data set head, you will get this. See, length, width, and the species. Now assign, sorry, X values and Y values. Got it. Splitting it to training data set, testing and training and test sets. Now we have the classifier. There's no change at all. See, skill learn 3 import recency classifier. So create recency classifier with gini. See, recency classifier criterion gini max depth is the same, no change. Whether it is in the recencies, whether it is a binary classification or multi-class classification, there is no change in the code. That is very interesting, isn't it? It may be, it's not so, it may not be the same with the other classifiers, but with the recencies, there is no change in the code. So see here, you get 0.9666. So this data is good. See, the same model we use, but we get a better accuracy for the multi-class classification. Okay, so multi-class, so the 3 by 3 matrix, 11 plus 24, 29 by 30. So we get a better accuracy for the IRI data set. But unfortunately, we don't get such an accuracy for the churning data set. Okay, having looked at all this, now what is left over is that we want to carry out regression using gini as a criteria. So that comes here. So here again only the regression will change, otherwise there is no change. Import the same libraries, read the file, social network adds, and the columns, and the head I'm printing. Then I have assigned the values 2 to 4, 2, 3, and 4 for the 2 and 3 for the x values and the 4 for the y value. Then I split the data set into training set and the test set. Done. So what the change is, import decision tree regression, not classifier. And create a decision tree regression by rig is equal to decision tree regression. Then rig dot fit x10 y10. So done it. Simple. All these changes you'll be able to use the decision tree as a regression for regression using criteria of Gini. And the RMS is good, 0.34. Not bad at all. To summarize, what we are saying in this lesson is we looked at the decision tree by Gini criteria. The accuracy was poorer for the churning data set, so we tried the same data set with entropy and it didn't improve the accuracy much better. It did not improve the accuracy much. However, when we did the multi-class classification using the array data set, we got the same accuracy in Gini also. See, we got the same accuracy with Gini also. I'll just show you this. Gini true. See, this is the accuracy we got yesterday also. Oh, sorry, in the lesson 1. So, 0.9, same accuracy we got. So, whether you use Gini or entropy, you get similar accuracies. And lastly, we took a regression example using Gini as the criterion. So, this completes the lesson. And try out all the 4 programs yourself in your computer. Only that will give you the confidence. You are free to use whatever I have given in your projects. You don't have to burn your midnight oil. You can use this and carry out your projects. Okay, that's all for now. Until we meet again. Bye bye.